Good day, everyone.
I'm Dato Leighton A. Mansakan.
And I'm Alistair T. Delgado. And we're going to discuss
geometric series
and P-series tests.
in advanced mathematics. Hello everyone, today we're going to learn about the geometric series test and how to determine if a geometric series converge or diverge. Let's get started. Converging means the sum approaches a finite number, while diverging means the sum goes indefinitely.
So now we have three examples here, so we can try to solve it. Let's go. Today we will solve the series. So let's solve this. We can bring down 1 over 3 to the raised to the n, and 4 times 4, 3n, then times 4 over 3 squared, because we separate them. Then copy the 1/3 raised to n. We factor out the n and solve the 3 squared. Copy again. 1/3. So let's factor out the n. Sorry for the mali. So we times the 3 squared equals to 9. Qn. So we have a common exponent, so let's times them. Copy the 4 over 9. Let's solve the 1/3 and 4/3. Let's copy the 4 over 9. Solve this. Equivalent of 4 over 9 n times 4 over 9. Let's move the 4 over 9 and 4 over 9 raised to n. Ito solve in calculator the 4 over 9, so equivalent to 0.44. So r less than 1 is converging. So move to the second problem. First, let's take a look at the series. The general term is 4 raised to n plus 2 raised to n over 3 raised to 2n plus 3. We notice that we have powers of 4 and 2 in the numerator and a power of 3 in the denominator. We can simplify this a bit by rewriting the power of 4 and 2 in terms of powers of 2. Let's recall that 4n equivalent to 2 raised to 2 times n, to 2 raised to 2n. So we can rewrite the general term as 2 raised to 2n over 3 raised to 2n plus 3. Now we can split this into two separate terms to make it easier to handle. Let's split the original sum into two series. Now we can treat each of these two series separately. Copy that. And let's factor out. So we 2 So we have the same 2 raised to n over 3 raised to 2n. So equals to 1 over 27 times 4 over 9n. Let's look at the first series. This is a geometric series where the first term is a 4 over 9 to the power of 3 and the common ratio is r equals 4 over 9. Since r less than 1, this series is converged. Now, let's use the formula for the sum of an infinite geometric series. S equals a over 1 minus r. Substituting a equals 4 over 9 raised to 3 and r equals 4 over 9. So, S1 equals 4 over 9 raised to 3 over 1 minus 4 over 9. So, calculate that equals to 64 over 7 to 9 over 5 over 9. So, need to reciprocate. So, 64 over 7 to 9 times 9 over 5. So, solve that. So, equivalent to 576 over 3645. So, the sum of the first series is S1 equals 1 over 27 times 576 over 3645 equals to 576 over 98315. Next to, let's simplify the second series. This is another geometric series where the first term is a equals 2 over 9 cubed and the common ratio is r equals 2 over 9. Again, since r less than 1, this series also converges. Now, let's using the geometric series sum formula. S2 2 over 9 cubed over 1 minus 2 over 9 equals to 8 over 7 to 9 over 7 over 9. So let's calculate 8, reciprocate. So 8 over 7 to 9 times 9 over 7 equals to 72 over 5103. So let's multiply by 127. 1 over 27 times 72 over 5103. So the final answer is 72 over 137781. Now, let's add the results of both series. ST equals 576 over 98315 plus 72 over 137781 equals to 6.40. So, R greater than 1 is diverging. Now, let's solve the number 3. First, let's simplify the term inside the sum. We have 9 raised to negative n plus 2 and 4 raised to n plus 1. Let's rewrite this expression number in terms of power 3 and 2. Now, let's generate terms becomes 3 raised to negative 2n plus 4. The next one is 2 raised to 2n plus 2. Let's simplify this further. Next, let's separate the power of 3 and 2 so we can group them. We can write 3 raised to negative 2n plus 4 times 2 raised to 2n plus 2 equals to 3 to the power of 4 times 3 raised to 2 negative 2n times 2 raised to 2 times 2 raised to 2 2n. So, let's factor out that constant. So, we have the 4 81 times 4 and 2 over 3 squared raised to n. So yeah, equals to 3 to 4 times 4 over 9n. So you have the final answer is converging.
Good day everyone. Next, I'm going to discuss the P-series test. The P-series test is a mathematical tool used to determine whether a specific type of infinite series called a P-series converges or diverges. This test is commonly applied in calculus and real-life analysis to analyze the behavior of series and determine their summability. P-series test can be used of the series is in this form. And these are the rules. P is greater than 1, that is converging. And P is less than or equal to 1, that is diverging. And these are my 3 practice problems.
In this video, we're going to talk about the P-series. So let's say, if we have the series form of 1 to infinity of 1 over n raised to p. Now, if p is greater than 1, the series will converge. If p is less than or equal to 1, the series will diverge. Now, let's work on some examples problem. Let's start with the harmonic series. So let's say that a sub n is 1 over n squared. So we can clearly see that p is equal to 2, which means that p is greater than 1. And so the series converges. Now let's move on to our next example. So let's say that a sub n is going to be the fifth root of n squared. So just like the last example, we need to rewrite the expression. So we need to change it from radical form and write it as a rational exponent. So this is the same as n raised to the 2 over 5 and this is over 1. So we need to put n in the denominator of the fraction. So we can rewrite this as 1 over n raised to negative 2 over 5. So we can clearly see that p is equal to this number. So if p is negative 2 over 5, that means that p is less than or equal to 1. So the series diverges. The infinite series of 1 plus 1 over the square root of 2 plus 1 over the square root of 3 plus 1 over the square root of 4 and so forth. So is this series, is it convergent or divergent? The first thing we need to do is write a general expression for each term in a sequence. So basically, we need to write an expression for a sub n. Notice that the value of the numerator doesn't change. So to write the formula, we're going to put a1. The second thing that doesn't change is the square root symbol. So we're just going to write square root but not the number inside the square root. The change for the first term is going to be 1. For the second term, it's 2. So for the nth term, it's going to be n. So a sub n is 1 over the square root of n. So now that we have this general expression, all we need to do is put it in the appropriate form. So the square root of n is the same as n raised to the 1/2. So now we have the value of p. So therefore, we could say that p is less than 1, which means that the series diverges.
And that is all, everyone.
And again, I'm Datoliton A. Mangansakan.
And I'm Alistair T. Delgado.
We
We
hope
hope
you
that you learned
learned something.
something. Thank you for watching.
Bye-bye.